Hey everyone, we're going to be going over pages 53 to 57 here in the note packet for today, which I know sounds like a lot, but this whole first page here that we're starting at doesn't have any problems, it's more explanation, and there's a couple extra pages that are primarily more you try it sections that I'm going to want you to try to practice here before we meet back up here on Monday. So, at this point, you just took the test yesterday. We briefly talked about a little bit of some rational functions with the domain and everything on pretty much Monday and Wednesday, and you have maybe one question on the test with it. But we really focused on excluded values in the domain. From pretty much this point forward, we're going to look at everything else. So then one of the main things we're going to be looking at are going to be asymptotes and what are called holes. So previously we looked at rational functions, specifically the ones like 1 over x or 1 over x squared, kind of like our power functions. We had vertical asymptotes and horizontal asymptotes that we saw on our graphs. Now, we didn't really do too much with them. We just knew they kind of existed. We knew that we were undefined, so that's why it kind of created some of those issues. So what we're going to be doing today is going to be figuring out how can we actually find exactly where those vertical and horizontal asymptotes are. And then we also have these weird situations where we get these things called holes, which are literally kind of like little blank spots in the graph. So the graph would be completely normal, except for like one little spot. It's kind of like an opening space because we do have an issue with an excluded value at that x value. Okay, so as we see here, we do have a kind of basic example of a rational function with some asymptotes. So we can see here we have the vertical asymptote here at the y-axis, okay, which means technically x equals 0 is undefined, right? The function is 1 over x, so plugging 0 for x, we also have an issue because we can't divide by 0, so that's a problem. What also happens is we have a horizontal asymptote at 0, okay, which we see here, and that's because we can't really get 0 as an answer. Now that's a little bit harder to kind of predict. There are a couple of methods. Well, there's one method, but there's a couple of cases that we look at to see what the answer is. So it makes it a lot easier. At first glance, it's kind of hard to tell what it might be, but we do have some shortcuts, if you will, some different methods to help us determine what that actually is. Okay, and this is all stuff we've seen before. We've seen a graph just like this. This is not like too interesting. Now, what is interesting is these holes. Okay, so what happens is we can have times where we have extra excluded values that don't produce extra vertical asymptotes. Now, some of the equations we're going to see might have multiple vertical asymptotes. They might have one, or they might have none. Okay, we kind of saw some similar things before back on Monday, where we found the domain, right? We found like maybe one excluded value or two or none. Kind of same concept. But with those excluded values, we could see instances where there's a vertical asymptote. In this case, is at x equals 3. So we're undefined at x equals 3, and it causes this vertical asymptote. But we also see an excluded value here at negative 1. But what's happening here is it's just a little blank spot in the graph. This is called a hole. Now, it's not too bad figuring out which is which. Okay, what we pretty much do is a process of trying to simplify. If we can simplify the fraction, if things cross out, they might cause a hole. If things don't cross out, they're going to stick with a vertical asymptote. Okay, it's really not too bad. At face value, it's going to look a little complicated, but once you do a couple of them, it's kind of the same thing every time. And, historically, every time I taught this, most people felt at first it might have been a little confusing, but once you kind of do a little bit of them, a lot of people actually think they're not too bad, which is ironic because a lot of people hate fractions, right? But people actually don't typically find these too bad. So we're going to take a look at a couple examples, kind of see how it works. So we're going to break it down the process step by step and see, how do we find everything we need. Right now, we're just going to focus on vertical asymptotes and holes. Once we kind of get that basis down and kind of feel comfortable, we'll look at horizontal asymptotes, kind of how they work. Okay, so if we kind of go down here, we do have a 5-step process. Okay, So I'm going to go over these 5 steps real quick, and I'll show you kind of how I do them, which is essentially the same steps, but I kind of may do things slightly different. But essentially, the first step is exactly what I do every time. We have to try to factor the numerator and denominator completely. Okay, so we got to break it down in smallest pieces as possible. Okay, from there, we should note any restrictions in the domain, which essentially is what we did before. We look at the denominator and see what x's are bad. We try reducing the fraction. So if there's anything the same in the numerator or denominator that can be reduced or canceled, we go ahead and try to do that. And what happens is when we do that process, anything that gets canceled becomes a whole. Okay? So if we reduce and there's x's that cancel, we have wholes. Okay, that's what step 3 is going to produce, is our wholes. Okay? Whatever is left over in the denominator is going to be a vertical asymptote. So we pretty much are looking for 2 things. We first simplify the fraction, and we look for 2 things. We look to see what cancels and what does not cancel. Okay? The canceling produces the whole. The not canceling in the denominator stays as a vertical asymptote. Okay? Now, we have 2 examples we're going to take a look at here first. Okay, we have x plus 5 over x minus 2. Then we have this one that's a little more complicated with some quadratics. Okay? So let's take a look at those first. So we pop over to the Jamboard here. So again, we're starting out with x plus 5 over x minus 2. Okay, I'm just going to leave off the function notation part because it's not entirely too important for us right now. So it's x plus 5 over x minus 2. Okay, so let's say you have this rational function, and we're trying to see if we have any vertical asymptotes or any wholes. First step, we factor numerator and denominator and see, can we break it down to smaller pieces? Well, in this particular example, that's not really possible, right? We look at the numerator only, x plus 5. There's nothing we can do. There's no GCF. It's not a quadratic. There's no fancy factoring techniques. It's just x plus 5. Same thing with the denominator. It's still x minus 2. So there actually isn't anything we can do to reduce it. Okay? Which means there's no wholes. Okay, so since we can't reduce, our wholes would be none. Come on. There we go. So we have no wholes. And then for the vertical asymptote, there we go. We look at the denominator, and we see, okay, what makes it 0? So if I take that denominator, x minus 2, I set equal to 0. When is this true? Well, when x equals 2, right? You could do it like that. Or we can use our shortcut. It's always the opposite of what you see, right? So it's x minus 2, we just get 2. So our vertical asymptote would be that value, so x equals 2. There you go. First problem's done. That's all we did. Okay, this example is very simple because there's not much that happens, right? So since we can't actually simplify this, we're forced to have no wholes. And then since we have no wholes, everything in the denominator, I just made that worse. Everything in the denominator is going to be a vertical asymptote. All right, that'd be fine. Okay, so whenever we're doing these problems, we want to see, can we factor? How can we reduce? What's left over? Okay, those are kind of the 3 steps that I do. I look at the fraction, I factor it, I try reducing it, and I see what's left over. So I break down into 3 steps. So that's kind of how I always do them. And it kind of covers the same basis. Okay, just to double check, it only wants us to find the vertical asymptote wholes. We're not doing anything domain and stuff like that, so this is sufficient. Okay? The next problem, right, so if you look further down on page 54, example 73, we have the function x squared plus 3x minus 4. So I'll go ahead and write that down. Okay, so we're going to split this kind of in half. So we have, what was it? X squared plus 3x. Minus 4. divided by x squared plus 2x minus 3. Okay, so in this particular case, we do see we have two quadratic equations in the numerator and denominator. So our first step is to try to factor. Okay, quadratic functions may be factorable, they may not be. Okay, we have a good chance that they are. So let's go ahead and take a look and see if this will work. So let's focus on the numerator first. Okay, so can we factor the numerator? So are there two numbers multiply -4 and add to 3? That there are two. We can use +4 and -1, right? 4 plus -1 is 3, and 4 times -1 is -4. So those will be my two factors. So we're going to go ahead with x plus 4. That's the first factor. Second factor is going to be x minus 1. Okay. Now, denominator. Are there two numbers multiply -3 and add to +2? It's kind of similar. This time will be +3 and -1, so we get x plus 3. And then x minus 1. And if I'm trying to simplify, we notice that there are two factors that are very similar. Right, we have x minus 1 on top and x minus 1 on bottom. So what's going to happen is we're going to actually cross these out. So these are going to cancel each other. And what's going to happen is we're going to be left with just a fraction of x plus 4 over x plus 3. Okay. Now, there's two things at play here. We know we canceled the x minus 1s to get this result. Okay? So that's going to give us a whole. So we crossed out the x minus 1s. So what's happening is we used to be undefined there. Right? That was an excluded value. We're excluded at -3 and 1. But since we cross out this 1 portion, the x minus 1s, what's happening is we're kind of like deleting that point. So we get a whole wherever x equals 1. So if we were to graph it, when we have x equals 1, we have to put an open circle at that point. Now, that's because we canceled it, right? Look at the first example, example 72. We did not cancel anything, so no whole. Here we did cancel something, so there is a whole. Now, what's left over tells us the asymptote. We see x plus 3 left over in the bottom, right? We're still undefined there at x equals -3. That's just our vertical asymptote. So our vertical asymptote is going to be x equals -3. Okay, so again, the process I'm doing, I'm taking the original fraction, factoring both numerator and denominator. Previously on Monday, we kind of ignored the numerator because technically we were only trying to get the domain, so we were trying to only look at the denominator only. Here, since we are now actually doing more than that, we factor both, if possible. We look to see if anything's the same, so the x minus 1s were the same, so they canceled. And then we're left with whatever's left over. In this case, x plus 4 over x plus 3. Now, the crossing of x minus 1s gave us a whole at x equals 1. Having x plus 3 excuse me, left over gave us a -3. Now, you're probably wondering, what does the numerator actually do? We're going to kind of get into some more details later, but they essentially are the x-intercepts. If you really want to know a little bit ahead of time. But for right now, I'm not too worried about that particular piece of information. So, if we go back to the note packet real quick, those are the two examples we got. Now, technically, the next section on page 55 are all eutriates. I mean, there's 4 of them here. I'm going to do an extra one. Let's do like B. I like B. Okay, I'm going to do B. I'm going to let you do A, C, and D on your own to kind of get that practice so we can go over these on Monday to make sure that everything's looking pretty good. So for B, we're looking at x plus 5 over x squared minus 5, or 25. Okay, so let's go ahead and try that one. So we'll pop up a new page here. So again, we look back at it. It's going to be x plus 5 over x squared minus 25. Write this a little bit bigger because we got a lot of room. All right. So let's say this is where you're starting. So in this particular case, we want to try to factor as much as we can, but only the numerator is not factorable, but we can factor the denominator, right? So we're kind of stuck with x plus 5 on top. But on the bottom, we try factoring this, we're left with 2 things. Difference of squares, so this is actually factorable, and so it's going to be x plus 5, x minus 5. So here's your x plus 5, and our x minus 5. Now what I'm going to do is I'm going to add some parentheses over the numerator's x plus 5. You don't need to, but I like to do that just because it's easier to see what's the same. And what we notice is we do have 2 things the same, or at least one pair of things the same. We have an x plus 5 on top and bottom, so they cancel, which means we have a whole. Actually, I'm writing in blue this time. So we have a whole that x equals -5. There you go, color coordinated. Look at that. Then the vertical asymptote okay, it's going to be what's left over. Well, what gets left over, right underneath it, it's 1 over x minus 5. So we have x minus 5 still. That's going to give us a positive 5 as the vertical asymptote. Okay, and what you'll notice is once you get comfortable factoring, like if you feel pretty good at factoring, these problems are pretty quick. Because you factor, cross things out, right? What's crossed out is a whole, what's left over is a vertical asymptote. And a lot of people like these problems because it's kind of an interesting feeling where you can factor these crazy problems and you delete a lot of stuff in the fraction and you're left with a nicer problem, right? We go from this to this, right? It's kind of satisfying. Some people like that. Okay. But no matter what, if we're trying to figure out holes in asymptotes, vertical asymptotes specifically, we got to make sure we are factoring as much as we can and crossing out anything that's the same. Whatever gets crossed out is a whole. Whatever's left over in the denominator only is a vertical asymptote. Okay, that's pretty much the main idea. So if you're looking at holes and vertical asymptotes, they come from the domain. The holes come from when things get canceled or reduced. Vertical asymptotes come from the things that are not reducible or not be able to get crossed out. Okay, so those are your holes and vertical asymptotes. Now, with these 3 examples, you should have enough information to kind of tackle part A. Part A is not too bad. Parts of it are factorable, parts of it are not. So you're going to see if anything cancels, and then you can write down your holes and vertical asymptotes. C, same thing. Some parts might be factorable, some parts might not. C, whatever cancels. Now, D is your challenge problem, because we did give you kind of a not so fun factorable problem on the top. Cases, remember, you had to do your A times C thing. Denominator is also factorable. So this is actually more of the challenge question. Okay? So at some point here after this video, make sure you go take a look at part A, C, and D. See if you can do it yourself and it makes sense. What we're going to do real quick is we're going to continue on to the horizontal asymptotes. And so we're going to talk about these a little bit. and we'll go from there. So, we talked about vertical asymptotes and holes. Let's look at the other portion of asymptotes, which are the horizontal. Okay? Essentially, these are broken down into 3 categories. Okay? And the 3, cases. That'd be a better word. 3 cases. So it's broken down into 3 cases. We have 3 different answers depending on what's going on with their degree. Okay? So if you recall, the degree of a function, of a polynomial, I should say, is the largest exponent, right? So what's going to happen is we're going to look at the numerator, see what the largest exponent is. Look at the denominator, look at the largest exponent, or its degree. We're going to compare. 3 things happen. If both polynomials have the same degree, meaning top and bottom have the same largest exponent, we divide the coefficients of the highest degree terms. So we just take the coefficient in the numerator, take the coefficient in the denominator, and divide them. That's it. Easy peasy. That's case 1. Either they're the same. Okay, if they're the same, we divide the coefficients. Case 2. What if the denominator has a large or lower degree? Meaning that the exponent on top is larger than the exponent on bottom, right? Well, the numerator, or excuse me, I said it backwards. The numerator is lower than the denominator. So the numerator is smaller, the degree or the exponent in the numerator is smaller than what's on the bottom, okay? I was trying to read it right the first time. If this is the case, if the denominator has the larger degree or the larger exponent, your answer is just 0. That's even easier. No math required, it's just 0. Okay? So if they're the same, you divide coefficients. If the bottom's larger, it's 0. In case 3, what if the top is larger? So what if the numerator is higher degree than the denominator? Well, then there's technically no horizontal asymptote. This creates what's called a slant asymptote. So instead of the horizontal asymptote being like horizontal, the asymptote turns on an angle, which is kind of weird. We're not going to get into too much detail on that, but that's what's happening, just so you know. There's still an asymptote being provided. It's just not horizontal, so we're going to say no horizontal asymptote. So these questions are actually pretty easy. You have to identify which case you're in. Are they the same? Is the bottom larger? Is the top larger? Those are your 3 cases. I'll say it again. Are the top and bottom the same degree? Do they have the same largest exponent? Is the bottom larger? So is the degree in the bottom larger? Does it have a larger exponent than the numerator? Or is the numerator actually the larger exponent? Okay. In these 3 cases, you're going to do one of 3 things. If they're the same, you divide coefficients. If the bottom's larger, it's just 0. If the top's larger, there's none. That's it. Okay, it's not too bad. So let's give a couple a shot here. Notice we don't have to factor, so factoring is not required. So we don't need to factor anything. We just have to look at what's the largest exponent. Okay, so let's look at example 75. For the numerator, we have a power of 2. So it's 2x squared minus x plus 2. Largest exponent's a 2. Denominator, 8x squared minus 8. That's going to be the largest one there. And we see they're the same. So we're essentially looking at 2x squared on top. That's the largest portion. 8x squared on the bottom. That's the largest exponent there as well. So if they're the same, we just divide coefficients. Okay? So if I write this out real quick to kind of showcase what we do, it's not too terrible. I'm going to write it down here. So we have 2x squared. Whoops, hit the wrong button. Minus x plus 2 all over 8x squared minus 8. Okay, so for this problem here, we only care about if there's a horizontal asymptote and what it is. So no factoring is required. I don't care about factoring in this case. It can factor. That's good for it. Not necessary. So what we're going to do is we're going to look at pretty much only these two pieces. Okay, this is the largest exponent on top. This is the largest exponent on bottom. Now just be aware, it may not always be the first term. Okay, we usually write it that way as like answering questions, right? Making our own stuff. But for the problems provided, you may not have the very first term be the largest exponent. So be very careful which one you're picking. But since they're the same, right, all we're going to do is just essentially say y equals the coefficient on top, so it's 2, divided by the coefficient on bottom, which is 8. So you get 2/8, which is just 1/4. There you go. There's your answer. I spent more time really explaining it in massive detail than this. Okay? This is your horizontal asymptote. Now, just point this out. Vertical asymptotes are x equals things. Okay, it's always x equals a number. Horizontal asymptotes are always y equals a number. So just keep that in mind when we're writing our horizontal asymptotes, that we are doing y equals instead of x equals. Just keep that in mind. Okay, that is a very, 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 very big thing. Okay? So in this case, we have the same exponent, we divide leading coefficients, and we're done. Okay? Let's look at the next one. Alright, so here's one where it's a little misleading. We look at the next example, 76. Let's find the horizontal asymptote of 9x plus 4 over negative 9 plus 3x squared. Well, I only have 9x on top, so my degree for the numerator is 1. Largest exponent is 1. Denominator largest exponent is 2. So the bottom's bigger, right? So if my bottom is larger, so the numerator's lower than the denominator, right? My answer is just 0. Okay, that's my horizontal asymptote, just y equals 0. So for example 76, I don't have to do any math. I just recognize that, hey, the bottom's bigger, right? The denominator has the larger exponent, so my answer is just y equals 0. That's it. So you just literally write in y equals 0, right? So if I was doing example 76, okay, I'm not going to write out the actual equation, right? If I'm doing example 76, right, I recognize that the denominator has the larger exponent, so my horizontal asymptote is just y equals 0. That's all I write. Done. That easy. Okay? So it's for horizontal asymptotes, it's more like analyzing the problem, analyzing the function, and picking out the pieces you need to make that distinction of what am I supposed to do. Right? If they're the same, we divide the leading coefficients. If they're the bottom's bigger, it's just 0. Now just be aware, they did not put this in order, so the 3x squared is at the end. That doesn't matter where it's located, alright? You have to identify which portion of the numerator or denominator has the largest exponent. So since this is x squared, right, 3x squared, that is the largest piece. Okay? Now we should have one more. In this case, we have 9x squared plus 4 over negative 8 plus 10x. So the question is, what's my horizontal asymptote here? Well, my degree in the numerator is 2, because it's an x squared. The degree in the denominator is a 1, so the top's bigger, which means my answer is just none. Okay, so since the top is bigger, my answer is none. Okay? So usually what I do when I do these problems, I look at them. Okay, these are the same. So I'll literally write down same and just be like, all right, y equals 2 over 8. Simplify if need be. I'll look at example 76. I'm like, okay, degrees 1 on top, degrees 2 on bottom. So I'm going to say bottom bigger. And then I'll say y equals 0. Done. For example 77, I look at the top, power 2. So I have my degrees 2. Look at the bottom, degrees 1. So top is bigger. So I'll just say, since the top is bigger, there's no horizontal asymptote, so be none. Okay, so you literally just write down none. Okay, so if I was really doing that one, what is that one? Example 77. Right over here. So I'm looking at example 77. This is how we'll literally write it. Horizontal asymptote. So HA. And I'll just put none. That's it. What you think is actually very complicated, it's not too bad. This is actually not a lot of like math calculation. It's more like understanding the relationship between the numerator and the denominator and how it affects everything. So essentially, if they're the same or equal, we divide the coefficients. If the top is smaller, meaning the bottom's larger, then we get an answer of 0. If the top is bigger and the bottom smaller, then we get an answer of none. And that's how it's always going to work. Okay? So, there are a couple U-triads here. Okay, so for parts A, B, C, D, I'm not going to do any extra. We covered pretty much every case. So I want you to go through and identify the degree of both the top and bottom. Okay, and see if they're the same or if one's bigger than the other, right? And just be careful, make sure you analyze it completely to make sure things are not necessarily in order. They're not always given to you in order, so don't just assume that it's always x squared over 5x squared. Okay, they're both degree 2. There could be a larger x when it's somewhere else in the problem. Okay, so just keep that in mind. So that's pretty much everything. So if you're doing horizontal asymptotes, you're just comparing the degree of the numerator to the degree of the denominator, and you're going to fall in one of these 3 categories. Okay, you have to remember those 3 categories and see which one you're in and what you do. But it's not too bad. That's pretty easy to remember. Okay, and then the other stuff we did, right, was the vertical asymptotes and holes. Again, you can follow this 5-step procedure, but I pretty much break it down 3 steps where we take the fraction, we factor it, we simplify it, and whatever gets simplified is a whole. Okay, whatever gets crossed out is a whole. Whatever's left over is a vertical asymptote. Okay, so for right now, leading up to Monday, the problems I want you to try on your own to see if you can kind of, figure it out a little bit. We go over it together. It's gonna be you try it 74 parts A, C, and D. We technically did B, and then for the second section, it's going to be the you try it part 78, which is parts A, B, C, D. Okay, I don't think these will take you too much. The factoring is not too bad for the ones you have to factor for, except for that one part. So I think it's going to be very doable. Okay, but we'll go over all these answers on Monday to make sure everyone's good. Like I said, these aren't like super hard problems, especially horizontal asymptotes. Those are probably the easiest ones. Just takes a little time to kind of make sure you're doing it correctly. But once you do a lot of these, it comes pretty naturally, and it's just a lot of factoring, reducing, and it's not generally too bad. Okay? If you have any questions, please email me. I don't care what time it is. Email me. I'll respond. Okay? Just because I'm not here doesn't mean that I'm not looking at my email. I literally got an email literally as I was doing this video. You probably heard it went off in the background. Okay? So make sure you get everything filled out. Okay, we'll go over anything else on Monday. If you have any questions in particular you want to ask in person, that's cool. Okay, we're going to go over these U-Triads together to make sure everything looks good. And if we need to go over more detail on something, we could definitely do so. That's not a problem. Okay, but if you have any issues and you work on this stuff and you're not really sure you have the right answer, or you're just saying, hey, take a picture, send it to me, and be like, hey, I just really want to know the answer because I'm trying myself crazy, do so. I can let you know if it's right or wrong. Okay, it's not a problem. Okay, definitely email me if you have any issues, when you check your work, anything like that. Definitely not a problem. Okay, besides that, this is going to be a wrap, and I'll see you guys on Monday.